All right, so we're picking up part 2 with number 20. Sketch the graph of the set of all points that solve each system of linear inequalities. So these are not equations, these are inequalities. So basically you're going to graph the function and then shade, and wherever the overlapping shading happens, that's your solution to your system. All right, go ahead and zoom in here a little bit. So we're on number 20. Okay. So number 20 looks a little bit interesting. It's definitely different than the example that they're telling you to see. See example 2. Example 2 is very similar to 21. So I definitely want to walk you through number 20. The first inequality is wanting you to include everything on your graph, all your x values from 0 all the way up to and including 125. So you're not including 0. I know that because it's strictly less than, but you're going from 0 all the way up to and including 125. I think what I want to do here is really emphasize what's happening with these compound inequalities, with these inequalities where it's almost like two separate things in one. So what I mean by that is I can rewrite this first inequality, and I can write that as x is greater than 0 and x is less than or equal to 125. So that's essentially what they have, is they have two separate inequalities, but they just kind of combine them and write them as one. How do I get x is greater than 0? Well, it's almost like starting with x in the middle and then looking backwards, right? If you viewed this from x's side, right, that's the greater than side for x. So one way you can think about it is like that. Another way is most people will just take those two things, they'll flip them. Okay, so instead of 0 on the left and x on the right, they just flip them. But then they also have to flip the sign. Okay, so make sure you flip that sign. So 0 is less than x is the same thing as saying x is greater than 0. They mean the exact same thing. And then for x is less than or equal to 125, I just rewrote that. So that's essentially what we want to graph, those two lines. X is greater than 0, x is less than or equal to 125. And let me show you how I did this. So what I did was I printed this off straight from our solution book that's available on Canvas. And I just kind of rewrote things and highlighted them using color. So hopefully that'll make more sense. So our first inequality, x is greater than 0. Where is my line x is equals 0? Well, this is that line x equals 0. So if I want to shade everything for x that's greater than 0, everything that's greater than that line, well, if you look, your your x-axis, it's the greater than to the right. That's the numbers that get higher and higher and higher. So from x equals 0, I want to shade to the right because I want to shade all the x values that are greater than 0. So for this line, I want to shade this line to the right. All my x values that are greater than that line. What about the other one? X is less than or equal to 125. Okay, so this line 125 looks like it's right here, this other blue line. That's x equals 125 is that line right there. And if I want to shade all my x values that are less than or equal to that, less than is to the left. So essentially, that's the reason why instead of writing these as two singular inequalities like that, they write it as a compound inequality where it's trapped between two numbers, because that's what you're doing. You're graphing the line at x equals 0, which is this. You're graphing the line at x equals 125, which is this. And then you're shading all the x values between those two numbers. The next one's a little bit trickier. If you notice, it's got x is greater than or equal to 2y, which is greater than 0. So you might be thinking, did they make a mistake? Is something else supposed to be there? Well, they didn't. They're just talking about this inequality in terms of y. So let me show you what I mean. What I can do from here is I can divide everything by 2. And just like in our first inequality where x is all by itself in the middle, I can do the same thing here. I can get y all by itself in the middle just by dividing by 2. So if I do that, x divided by 2, there's nothing I can do to simplify it. I'm going to write that as 1/2 x just because that looks better to me. Still greater than or equal to. I'm not changing that. 2y divided by 2 is just y. And then 0 divided by anything is 0. So this is the same thing as up above, where I can take this compound inequality and rewrite it as 2 separate inequalities that might make it easier for you to graph, at least at the beginning here. So I'll rewrite this first one as an inequality. So remember, we'll start with y and we'll kind of work backwards. So if we start with y and work in this direction, it's going to be y is less than or equal to 1/2 x. Okay, remember, another way you can think about that is taking 1/2 x and y and flipping them. But if you do that, you got to flip your sign. And then the other inequality is just y is greater than 0. So unlike the first inequality where they're talking in terms of x, now they're just talking about y's. They want to talk about my y values. So y is less than or equal to 1/2 x. If I told you graph y equals 1/2 x, hopefully you'd graph this line right here. Right? The y-intercept is 0. It's 1/2 x plus 0. And then my slope is 1/2. So up 1 over 2, up 1 over 2. So that's that line right there. I want to shade all of my y values that are less than that line, less than or equal to. Remember, less than means lower than in this case when we're talking about y values. So less than means lower than this line. So that's that, right? I think you get the hint there. And then the other inequality, y is greater than 0. Remember, just think about it as an equation to get the line. Y equals 0 is this line right here. It's a flat line at y equals 0. And then you want to shade all your y values that are greater than 0. So greater means up when you're talking in terms of y. All right. Then our last one. 2x plus 2y is less than or equal to 300. So this looks like very similar to the one that's in example 2. Let me scoot this down a little bit. Essentially with this last problem, all you're trying to do is just simplify it. So we're going to divide everything by 2. And then we'll get x plus y is less than or equal to 150. So in this case, you can't really graph that the way it sits. The way you need to graph it when you have x and y is you've got to put it in that form y equals mx plus b. Even though this is an inequality, it still needs to be in that form. So in this case, I'm going to subtract x from both sides, and then I will create the line y is less than or equal to negative x plus 150. So just a little bit of manipulation there. Divide everything by 2 just to simplify the problem, and then set it in that form y equals mx plus b. So here's my line right here. So again, when I'm going to graph this line before I shade it, I'm going to think about it in terms of an equation. Y equals negative x plus 150. So 150 is my y-intercept. Obviously, that's off my page. And then my slope is negative 1. So I start off at 150, down 1 over 1, down 1 over 1, down 1 over 1. Because that's off the page, if I was being asked to graph that, I would just pick an x value where it would land on my page. So for example, if I picked x equals 60, right? If I pick x equals 60 and I plug that in, negative 60 plus 50, or I'm sorry, negative 60 plus 150 is 90. And that fits on my page. So I would be able to graph that point. So I'm not able to just simply plot my y-intercept and apply my slope with this problem because it's off my graph. If you had a bigger graph, you could. So if you can't, just pick an x and y value and start plugging in numbers. Once you get 2 points, you can create a line. So for example, if I plugged in 60, I would get 90. Try to plug in like 120. I don't know. Negative 120 plus 50 is 30. 150 is 30. So 120 up to 30, and it would be right there. So you might have to create a line. It might not be able to be graphed with the y-intercept and the slope. So there is that line. This inequality is y is less than or equal to that line. So less than or equal means lower, down. Here's the part where it's visually tricky. So you have to take a step back and you have to look at this problem. And you're looking to see where all of this stuff overlaps. If I pick this point right here, right? If I pick this point right here, well, the blue inequality overlaps, it shades on it, right? The pink inequality shades on it, but the green doesn't shade on it because it only shades between those two green lines. So that's not going to work. If I pick something like right here, right, it looks like the green inequality would shade on it because this goes down and this goes up. But the blue and the pink wouldn't, right? Because the blue is just trapped between these two lines and the pink just shades down. So if you look at this, it's a little bit tricky, but you can basically see that any point inside of this little triangle right here, like any of those points that I just drew, that all is in that triple overlap region. So watch. The blue overlaps inside of that. The pink overlaps inside of that. And then the green overlaps inside of that. So the area you want to keep is right here. I'm going to outline it with a black marker. So anything inside of that area right there is a solution to that system of equations. All right, let's take a look at 21. So 21 is very similar to example 2, just like they're referencing there. With this first inequality, you'll notice that it's not in y equals mx plus b form. Remember, that's kind of the form we need to have things in if we want to graph them. Okay, so if I go ahead and subtract 2x from both sides, I'm going to have y is less than negative 2x plus 10. So there's my first inequality ready to graph. The second inequality, x minus 2y is less than 8. A little bit more work here, so I'll go ahead and rewrite it down here. So I'll have to subtract x from both sides. And then I'll have to divide both sides by negative 2. So here's that caveat when it comes to inequalities. When I divide or multiply both sides by a negative number, that sign's going to flip. So here we go. I've got y on the left. Because I divided by negative 2, this less than is going to become greater than. Negative x divided by a negative 2 is just 1/2 x. And then 8 divided by negative 2 is negative 4. So I've got my second inequality. The third one and the fourth one are set up. They're simple. X is greater than 0, y is greater than 0. So those are ready for you to go. All right, so if I go and graph this line, it's going to look something like this. And just for the sake of me saving you from my crappy graphing skills and horrible like penmanship and everything, I went ahead and printed these off just so that way you can see. If you were being asked to graph these, and I think they are asking you sketch a graph, I would just encourage you to go to Desmos and just click on that and graph it. That way you can visually see what they're talking about there. If you want to hand sketch these things, that's fine too. If we were in class, we would, but these are kind of hard to hand sketch and make them look nice, and not everybody has graph paper and whatever. So let's go ahead and figure out what all these lines are. So let's start off with the first one. Y is less than negative 2x plus 10. So that means my y-intercept is at 10, and then my slope is negative 2. It looks like there's only one line that's that case, so that's got to be this line right here. The second inequality, y is greater than 1/2 x minus 4. So that means the y-intercept is negative 4, and it's got a 1/2 slope. So negative 4, up 1 over 2, up 1 over 2. Looks like that's my line. X is greater than 0. So remember, x equals 0 is going to be one of these vertical lines. That's x equals 0. And then the last one, let me get a different color. I don't think I have a different color. So we'll just do this. Y is greater than 0. Unlike x is equal to 0, that being a vertical line, y equals 0 is a horizontal line. So that's going to be this one right here. And now we can kind of look and see where all this stuff is overlapping. So y is greater than 0. That means you're going to shade above it. So everything above that line. Y is less than negative 2x plus 10. So that means everything lower than that line. You can see how crazy this can get once you get too much stuff on here. Y is greater than 1/2 x minus 4. So that's above that line. And then the last one, x is greater than 0. So all of my x values that are bigger than 0, that are greater than 0, are going to be to the right of that line. So everything to the right. So it's kind of chaotic. You can kind of see how this can get really messy, but if you can visually kind of focus on the part where there's, in this case, a quadruple shading effect, it looks like it's going to be this part right here, this triangle. Okay. All right. So that is 21. Take a look at 22. Solve the following system of equations. So this is the one where you can either do it graphically, use elimination, or use substitution. It's totally up to you, whichever one you want to use. You can go back and reference example 3. I haven't really looked at this, so I'm probably going to use elimination just because there's 3 different variables there. So that's my plan. All right, so number 22. Like I said, I think we're going to do this with elimination. It looks like it's pretty much set up for that. If you just had 2 variables and one of your equations was solved for x or y, I would use substitution. But three variables, it's a lot more difficult. So it's your choice. You could really eliminate any of these variables from any of these equations. So what I start doing is I scan it. So I'm looking at x's. Is there any way I can add or subtract any of these equations together, any 2 of them, to eliminate an x? No, right? 3x minus x is still 2x. 2x minus 3x is negative x. I can't add or subtract any of these equations to eliminate x. What about y? Well, it looks like the first and the second equation, if I add these 2 equations together, negative y plus y is 0y. So if I do that, that's going to eliminate my y variable. So that's what I'll do. I'll add equations 1 and 2 together. 2x minus y minus 3z equals 20. 3x plus y plus 6z equals 4. I'm going to switch to a pen. So if I add these two together, 2x plus 3x is 5x. Negative y plus y is 0y. Negative 3z plus 6z is 3z. And then 20 plus 4 is 24. So this was equations 1 and 2 that I added together. So now what I'm going to do is either use equations 1 and 3 or 2 and 3. It's up to you to eliminate y. I think in this case, I'm going to have to multiply either 1 or 2 by something to make y drop out from the third equation. So if I have equation 3, I'll have x plus 2y plus 9z equals negative 16. This was equation 3. And I think what I'm going to do is I'm going to go ahead and multiply the first equation by 2. So I'm going to rewrite out the first equation. 2x minus y minus 3z equals 20. That's the first equation. But I want to multiply it by 2. And hopefully you can see why I want to multiply it by 2. When I multiply all 4 of these terms by 2, then I'll have a positive 2y and a negative 2y. So I'll be able to cancel out my y's. So I'll go ahead and rewrite these. Again, the third equation, x plus 2y plus 9z equals negative 16. If I multiply the second, or this equation here, equation number 1, if I multiply it by 2, everything gets multiplied by 2, even the 20. Make sure you do that. So 2 times 2x is 4x. 2 times negative y is negative 2y. 2 times negative 3z is negative 6z. 2 times 20 is 40. So now if I add these two equations together, 4x plus x is 5x. 2y minus 2y is 0. 6z minus 6z is 3z. And then negative 16 plus 40 is 24. Now take a look at what I've got. After I do that, after I added equations 1 and 2, and then I multiplied equation 1 by 2, so if I added equations 3 and 1, I was able to cancel out y in both of those. Could I have chose a different variable? Sure. You could have chose x or z, it doesn't matter, but y just to me was the easiest way to go. So now I've got these two equations. I've got 5x plus 3z equals 24. 5x plus 3z equals 24. And now if I look at this, again, take a step back. You're looking at eliminating one of the two variables. It doesn't matter which one. In this case, it's kind of a unique situation. If I subtract these two equations, remember, there was those 3 properties back on page 49 that state you can rearrange these equations, you could multiply the equations by something, or you could add the equations together. When they say add, adding is the same thing as subtracting. So instead of subtracting this, you could think about adding the negative. So when they say adding the equations is acceptable, subtracting is also acceptable. So if I subtract these two equations, what do I get? 0, 0, 0. So essentially what I get is 0 equals 0. This is the type of situation similar to the one that we went through in the example a little while ago that was no solutions possible. This is a true equation. All of your variables dropped out. There's no more x's, no y's, no z's. So all the variables dropped out and you have a true equation. You could also have something like -3 equals -3 or 20 equals 20 or whatever. But all the variables are gone. 0, in fact, does equal 0. So this is infinite solutions. You could basically pick any number under the sun, plug them in for x, y, and z, and it would always be true. It would always give you a true statement. Number 23, another example of systems. So let's take a look at this. Looks like if I add the second and the third equation together, this is equation 1, equation 2. I just like doing this so then I'm naming them. If I add equation 2 and 3 together, I think I'm going to be able to cancel out my x's. -x plus 3y minus 2z equals 13. So if I add these two equations together, x plus -x or x minus x, same thing, that's 0. -2y minus 3y, that's -5y. 4z minus -2z, that's 6z. -12 minus 13 is -25. So in this example, we used equations 2 and 3, added them together, and we eliminated the x. Now in that step, let me make it clear, you could have eliminated x, y, or z, completely your choice. But now that I've done that first step right there, now I must eliminate z. All right? Oh, I'm sorry. I must eliminate x. I'm misspeaking. Because I eliminated x in the first step, now whatever two equations I use, I have to eliminate x. So in my first step, I chose equations 2 and 3. Since I didn't use equation 1, I have to use equation 1 in this next step. You've got to. No choice. You've got to include that equation. So you've got to use equation 1. Now it's your choice. You can use equations 2 or 3, whichever is going to make it easier. I think either 1, 2, or 3, you would still have to multiply. So it really doesn't matter which one you want to use. I think I'll go ahead and use equation 3 just because it's already negative. In equation 1, the x value is positive. So that way it would just kind of eliminate out. So let's get equation 3 on here. -x plus 3y minus 2z equals 13. And what I'm going to do is multiply that by 2. Again, in that first step, we eliminated x. So in this step, I have to eliminate x. I can't eliminate a different variable. So I'll go ahead and distribute this 2. Everything gets multiplied by 2. Super important. You can't lose something because then nothing will work out. So what I have now is I've still got equation number 1, 2x plus 5y minus 3z equals 14. But my new equation 3, 2 times -x is -2x. 2 times 3y is 6y. 2 times -2z is -4z. 2 times 13 is 26. So if I add these two equations together, my x's drop out. My y's is 11y. My z's, that's -7z. And then my constants on the other side is 40. All right. So from the start, we just looked through here. We chose x, y, or z. It doesn't matter. You can eliminate any of those variables. But because we chose x in the first step, we had to eliminate x in the second step. Also, let me make one more thing super clear. Because we chose equations 2 and 3 in the first step, you could have chosen 1 and 2 or 1 and 3. It doesn't matter which 2. But because I chose 2 and 3, I have to include equation 1 in the second step. It doesn't matter if I use 2 or 3 as the second equation. It's up to you. But I have to use equation 1 as one of those equations. All right, now I've got these two kind of new equations. So let me go ahead and write those down. -5y plus 6z equals -25. 11y minus 7z equals 40. As this sits, if I add or subtract these two equations, nothing's going to eliminate. Okay, so what I need to do is I'm going to have to multiply one or both of these equations by something to force them to eliminate. So I think I'm going to go ahead and do the y's. And here's the first thing that stands out for me. If I take this first equation and multiply it by 11, and I take the second equation and multiply it by 5, what's that going to give me? Negative 55y plus 66z equals negative 250, 275. I got to make sure that that's right because otherwise it's going to get us all screwed up. 25 times 11. Perfect, 275, negative 275. Then the second equation, 5 times 11, that's 55y. 5 times negative 7z, that's negative 35z. 5 times 40, 200. All right. Why did I choose that? Well, all I did was I looked at y, negative 5y and 11y, and I just thought, what can I multiply both of those equations by to make them basically opposites of each other? One's negative, one's positive. That's key because you want to make them drop out. You want to make them eliminate. One go-to is you can always multiply the first equation by the second coefficient. Then I would multiply the second equation by the first coefficient. Doesn't matter what the number is, you know. For example, I could have eliminated z. I could have multiplied the top equation by negative 7. I could have multiplied the bottom equation by positive 6, and then they would have eliminated. So here, if I add these together, my y's drop out. 66 minus 35 is 31. Negative 275 plus 200 is negative 75. Divide both sides by 31. And I get z equals I think I made a math error because it's not a fraction. So let's see. Let me try to track this down. 11, 55, 66, negative 275, 55, negative 35, 200, 31, 0. Give me just a second. Let me see if I can track down my mistake. All right, I figured out my mistake. You might have been wondering like, oh my gosh, he's using tons of ink there, right? He's writing every single step down. He's writing the step down where he's showing that he's multiplying it by 2 and then rewriting out the equations. And the reason I do that is because typically when I do that, I make less mistakes. Notice I don't say more mistake or no mistakes because mistakes always happen. It doesn't matter what you're doing or how much you write out. But I think I figured it out. And probably everybody watching this was like, oh, it's right there, Chapman. I think it's right here. So I did negative 2y plus 3y. So that part right there should have been, so this equation should have been a y plus 2z equals 1, right? So initially I just saw that, but now I realized that I basically added everything wrong. I think what essentially I did was I subtracted everything. I saw x minus x and I thought negative 2y minus 3y. That's how I got all this stuff as I subtracted. But technically I'm adding those because that was already negative in that third equation. So I need to add each column. So negative 2y plus 3y is y, 4z plus negative 2z. That's 2z, negative 12 plus 13 is positive 1. Now I think I'm set up and ready to go. I thought they were throwing a curveball at you and making you have fractions, but that would have been nasty. So let me please ignore all of that there. Let's start fresh over here. So my first new equation is going to be y plus 2z equals 1. Let me just double check, make sure I didn't screw anything up over here. I'm adding these two, so add, perfect. So 11y minus 7z equals 40. So excuse my mistake, I apologize. This is a little bit easier actually, because if you look, this should be 11y. Man, this is an 11, this is a 1, so all I have to do is multiply this top equation by negative 11, and then it's going to drop everything out, or at least the y's out. So negative 11 times y is negative 11y, negative 11 times 2z, that's negative 22z, negative 11 times 1, that's negative 11, and then my second equation, I'm just going to rewrite it, minus 7z equals 40. And now I can just basically add these two equations together. The y's drop out, negative 22z minus 7z, or negative 22z plus negative 7z. It doesn't matter how you think about it. Negative 29z. Negative 11 plus 40, that is 29. That looks a lot better. So now I can divide both sides by negative 29, and I get z equals negative 1. So there is the first of my three variables. Now what I'm going to kind of do is work backwards and start plugging things in. So I already found out that z equals negative 1. So you can go back to either one of these equations and solve for y. You wouldn't want to go back to your first three, like the first three initial equations, because if I just know z, well, then I'm still going to have two unknowns, and that's not going to help me. So once you solve for one of your variables, just go back to this step right there and plug it into either one of those. It doesn't matter which one. So I'll pick the first one because that just seems a little bit easier. So y plus 2 times negative 1 equals 1. So I'll go ahead and write that down here. Y plus 2 times negative 1 equals 1. 2 times negative 1 is negative 2. So what I'll have to do is add 2 to both sides. And I get y equals 3. So now I've got the second of my three variables. And now is the part where you'll go back to the initial three equations and pick any one of them. I always pick the smallest numbers, maybe the most positive numbers, things like that, just to kind of make it easy on myself. It looks like I'm just going to go ahead and pick equation number 2. So I'm going to go ahead and plug in the fact that z equals negative 1 and y equals 3 into equation 2. So we don't know what x is. Y is 3, so minus 2 times 3. Z is negative 1, so plus 4 times negative 1, and that equals negative 12. So I took y and z, I plugged them into equation 2. You could have plugged them in equations 1 or 3, it doesn't matter. Give you the same problem, same answer. So what do I have here when I start simplifying? Negative 2 times 3 is negative 6. 4 times negative 1 is negative 4. Negative 6 minus 4 is negative 10. So I'm going to go ahead and add 10 to both sides. And I get x equals negative 2. So my answer for number 23 would be x equals negative 2, y equals 3, z equals negative 1. So sorry about that confusion back here at the beginning when I screwed us up. But if you ever get down to a problem like an answer what we were doing and you get negative 75 divided by 31 and you're like, oh, that's a fraction. Is it a fraction? You can always go check the key, the solutions manual. And then if you check and it's not a fraction, just do what I did. I just paused the video and I started back up here at the beginning. I made sure that I wrote the problems down correctly. I made sure when I added them, they were correct. And then as soon as I added that column, I knew I screwed up. So I just traced my steps backwards. All right, number 24, write the augmented matrix for each system of equations. See example 4. So if you don't remember what this was talking about, this is back on page 50. So remember there's 3 types of matrices here. The first one is just a matrix. The second one is a coefficient matrix, but what they're wanting you to write is the augmented matrix. So these should go pretty quick. So for number 24, the augmented matrix for this. Remember, the key with an augmented matrix is you can't have any gaps. If I was missing a y in the first equation, I'd have to have a 0 there. So an augmented matrix for this one, it looks like it's going to be, it's a 2 by 3 because it's always rows times columns. So I'm going to need 2 rows and 3 columns of information. The first coefficient's a 1. The second coefficient's a 1. And then the constant on the other side of the equation sign is a 2. You can make a dotted line. I think they reference a dotted line in here. Yeah. If you want to just draw a straight line like this, that's fine too. Gets the point across. Coefficient of x for the second line is going to be a 1. Coefficient of y is a -2. And then the constant on the other side is a 17. So it should look something like that. Number 25, same idea. So draw myself my little bracket. Again, this is a 2 by 3 because there's 2 lines and then there's 3 columns of information. We're going to have to rearrange that first equation though, because remember, these things have to be written in standard form. The second line, the second equation is in standard form. X is first, then y, and then the constants on the right side of the equation. So I'm going to rewrite this first equation in standard form. I'm just going to subtract 2x from both sides, and I'll have -2x plus y equals 0. And then my second equation, 4x minus y equals 9. So there are my system, or there's my system that's in standard form, and I can plug it in now. So a -2 and a 1, and a 0 on the right side. A 4, a -1, and then a 9 on the right side. So there's my augmented matrix. The key here, again, if you're missing a term, make sure you have a 0 in its place. If something's not in standard form, you got to make it in standard form, and then you could put it into an augmented matrix. 26, it looks like we've got A, B, and my constant on the right. Looks like we've got A on the left, B on the right, so very similar to number 25. I'm going to go ahead and subtract 1/2 B from both sides. So I'll have my first equation, 10A minus 5B equals 3. And then my second equation, A's got to come first. Alphabetically, that comes first, so that has to come first in my problem. Minus 1/2 B equals 0. So my augmented matrix, 10, -5, 3. 1, -1/2, 0. And then same thing with 27. It's not in standard form. Either one of these aren't in standard form, so I'm going to have to manipulate them both. I think with the first equation, all I'm going to have to do is subtract 7n from both sides, and then I'll be good to go. So if you think about it alphabetically, m comes before n, L, M, N, O, P. So I'm going to have m first, then I'll put my n term, and then my constant that's already on the right-hand side. Same thing here. There's a couple things you could do. You could subtract the 1 and then subtract the m. You could just flip the sides. I think I'll just walk you through what I would do. So I guess I'll just go ahead and subtract m from both sides. That'll give me -m plus 1 minus n equals 1. Now I'm sorry, equals 0, because there's nothing else on the right-hand side now. And now I'd move that constant over to the right-hand side. So I'd subtract 1 from both sides. I'll have -m minus n equals -1. All right, so here we go. There are my two equations. So my augmented matrix is going to look like this: a 1, -7, -1. A -1, -1, and a -1. If you wanted to, you could divide all those by -1 to make them all positive. It doesn't really matter. Same thing. All right. We're getting down to it. 28. Write the system of equations described by this augmented matrix. So now we're just going in reverse. So for number 28, use X and Y, use, A and B. It doesn't really matter what you use. We'll just stick with X and Y. They're specifically saying this is an augmented matrix. So I'm not sure why they don't have their line here for the equals part, but they should. Maybe it was just a mistake in the text. So I'm going to go ahead and add that line. So I have 2x minus 2y equals 4. And then I have x plus 2y equals 11. Same thing with 29. Again, they don't have the line there, so I'm just going to add it. Remember, this is going to be the coefficient of the first variable. This is going to be the coefficient of the second variable. This is going to be what your equation equals, the constant on the right-hand side. So I guess I'll just pick different letters. I'll pick, B. So this is 0.5b plus c equals 0. And this is negative b plus 4c equals 2. It doesn't really matter which variables you use, just as long as they're in standard form, like they go in order. So if I use something like A and F, A would come first, F would come second. And then numbers 30 and 31, couple word problems. Charles has a collection of dimes and quarters worth $1.25. He has 8 coins. What are systems of equations and an augmented matrix that can represent this situation? So he's got a collection of dime and quarters worth $1.25, and he has 8 coins. So that's telling me 2 pieces of information. So I think I have 2 equations here. I'll use D for dimes and Q for quarters. If you want to use X and Y, you could. I think it says I have 8 coins. So if I take the number of dimes plus the number of quarters, I should have 8 of them, right? That's just talking about the number of actual coins. The second one's going to talk about money. So the number of dimes plus the number of quarters has to add up to $1.25. So we all know dimes is worth 10 cents, quarters are worth 25 cents. So it's going to be 0.10D plus 0.25Q equals 1.25. Again, just to be clear, one equation is talking about the number of coins. One equation is talking about how much they're worth. The number of dimes plus the number of quarters, guy has to give me 8 coins. Since dimes are worth 10 cents, I'm going to do 0.10 times D. Quarters are worth 25 cents. It would be 0.25 times Q. And once I know how many dimes and quarters there are, I can plug in those values, but they have to add up to $1.25. I think it wanted the augmented matrix as well. So the first equation would be 1, 1, 8. The second equation would be 0.10, 0.25, 125. It's not asking you to solve it, I hope. Nope, just asking you to create those. 31, a set of rectangular and square tiles contains 50 pieces and 170 sides. Write a system of equations and an augmented matrix to represent this situation. So super similar to what we were talking about just a little bit ago. Same type of problem. You're just going to create the system and then create an augmented matrix. So the first thing that it's saying is the triangular and square tiles. So I'll go ahead and use T and S. That just makes sense in my head. Triangular. S is square. It's telling me I've got 50 of those. So a lot like number 30, since I have 50 of those tiles, I can just take the number of triangular plus the number of square, and it should give me a total of 50 tiles. And then the other piece of information is this talking about the number of sides. So again, just like with dimes and quarters, I knew dimes were worth 10 cents, quarters are worth 25 cents. Well, I know that triangles have 3 sides, and I know squares have 4 sides, right? For a total of how many sides? 170. So the first equation is talking about the number of tiles we have. The second equation is talking about how many sides for triangles, squares, and total number of sides we have. So in augmented matrix, we're finally wrapping this up. Is 1 150, because that's a 1, and then it's equal to 50. 3 4 170. And that's it. Good luck if you made it this far. Good luck with this section. If you need anything from me, please let me know, and I'd be happy to meet with you and talk about these problems in more detail.